The Triassic period was rife with all sorts of completely bizarre life forms. Sure, most of Earth's past is filled with that sort of stuff, but the Triassic had just a ton more of it. Life was bouncing back from the biggest and nastiest mass extinction the world has ever seen, the Permian Mass Extinction, and animal groups were taking every and any ecological niche they could, evolving into the weirdest forms of life to ever scurry or scuttle on land, or even in the sea. Over 80 fossils of a very small weirdo among a cornucopia of weirdos have just been described. It not only has a completely novel form of display, but it also solves a half-century-old mystery about some funny little reptiles from the time before the dinos. Everyone knows that animals can go extinct. It wasn't always like that, of course, but any moderately educated person can probably understand the basic concept that if all of a certain species is killed or harmed, there will be no more of that species. The death of an entire species occurs all the time, but no more often than during mass extinctions, usually triggered by major shifts in the Earth's life cycle. Out of all of the many proposed mass extinction events throughout Earth's laborious history, there are only 2 or 3 that most of these moderately educated people may know of or remember. The one that resulted in the end of the Ice Age megafauna, the one that killed the non-avian dinosaurs, and the biggest, nastiest one at the end of the Permian period that killed off 81% of marine species and 70% of terrestrial species. Based on the fossil record, scientists have hypothesized that after a major mass extinction, life takes thousands to around 1 million years to bounce back, and from there, it's off to the races for which animal groups will take over the empty niches that were once ruled by different animal groups. So, one might expect a huge explosion in diversity of form right after the biggest and nastiest mass extinction in the history of life on Earth. The one so devastating that it's earned the nickname of the Great Dying. That expectation is right on the money, as animal groups that survived the end Permian mass extinction entered into an arms race for whoever could develop the highest metabolisms, weirdest integumentary structures, and most upright gaits. An evolutionary arms race for who could be the coolest, fastest, and freakiest. This is why the Triassic period is something of a meme amongst paleoenthusiasts and paleontologists alike. The majority of the time, when the Triassic is brought up in these sorts of videos, it's centered around the Triassic fauna of North America. You can thank jingoism for that. However, there are plenty of spots on the planet that spill their Triassic secrets ad nauseum, like Brazil, China, and South Africa. However, what about the places that remain mysterious? What about the time periods that led to the late Triassic? Let's take France, for example. Not much is known from the Triassic of France. Well, not much in the way of large terrestrial critters anyways. A handful of cynodonts, the precursors to true mammals, are known from late Triassic sediments, but not a strong dinosaurian fauna. Some potential Plateosaurus bits are known from late Triassic Maine de Chelon, and the very fragmentary theropod Lophostropheus is known from the boundary between late Triassic and early Jurassic of Normandy. Despite this, there are many sites that produce a lot of non-dino fossils preserving all manner of details, like the chitinous exoskeletons of creepy crawlies. Alsace is a rather fossiliferous region of France between Vézelon and Forbach among the Vosges Mountains. Several layers of Triassic rock are exposed here, including the Grès à Melue, Grès à Argelou, and Grès Coquillifère, which compose the larger Grès à Voltsia formation, which dates to roughly 247 million years ago, or the Anisian stage of the Middle Triassic. It's been known to locals for over 100 years, but its paleontological value was not fully realized until renowned fossil collector Louis Grouvogel started collecting, organizing, and studying hundreds of fossils from the quarries as far back as 1935. Grouvogel collected mostly plant and insect fossils, so numerous and well preserved as to warrant calling the quarries, the formation to which they belong, and the general fossil-producing region a logostat, which is a geologic outcrop or formation that preserves very fine details of soft tissues and in high abundance. Over the course of his life, Grouvogel's collection amassed quite a reputation amongst paleo people, both professionally and recreationally. Among his collection happens to be a comparatively small grouping of very similar fossils belonging to a vertebrate animal that has only recently been identified and analyzed as something beyond extraordinary. On a balmy day in May of 1939, Grouvogel found two teeny tiny skeletons in the middle of the Grès Amule section of the Grès Voltsia formation. One was identified as a reptile and the other as a fish. Both would go pretty much entirely unremarked upon until 2019, 80 years later, when the collection was moved to the State Museum of Natural History of Stuttgart, Germany. It had been in the possession of Grouvogel's family until that time. Grouvogel's daughter, Dr. Lea Grouvogel-Stamm, inspired by the world around her and her father's passion for the earth sciences, became a paleobotanist and dedicated herself to studying her father's collection. Once the collection had been transferred to the museum, Dr. Grouvogel-Stamm and colleagues at the museum were able to give a more thorough and concerted analysis of all the fossils. This led to a re-evaluation of the two vertebrate fossils from 1939. The researchers found that both belonged to the same animal and that 80 other specimens in the collection also contained an appendage belonging to the same type of animal as the two skeletal specimens. To cut to the chase, the two main specimens are of a very weird little reptile. Lead author Stephen N.F. Speakman and a huge team of researchers from Germany, Switzerland, Ireland, England, Italy, and France published their work on these little guys in July of 2025 in Nature. Here are those two specimens. Is it just me, or do they look like a lizard laying on top of a giant one of those seed pods that falls from trees like a helicopter blade? And why does this all feel so familiar?
Something very familiar about all this.
The specimen that was originally thought to be the fin of some fish, SMNS 97278, turned out to be a large fin-shaped feathery structure erupting from the humped back of a small reptile. The reptile part of which was revealed when the German museum was able to do a little bit more prep work on the fossil. The other fossil, SMNS 97279, was just the skeleton of the same type of reptile, missing the back fan. The author team conducted synchrotron radiation microcomputed tomography scans, synchrotron rapid scanning X-ray fluorescence scans, UV-induced fluorescence exposures, and scanning electron microscope analysis on the fossils to get to the bottom of what the feathery things are and to reconstruct the badly squished fossils of the animal. When all that was said and done, this is the reconstructed skeleton of the animal that the team named Mirasaura Grouvogeli, meaning Grouvogel's wonder lizard. However, it turns out this little guy is anything but a lizard. Once the team could see every single bone in Mirasaura's skull and reconstruct it along with the bizarre vertebrae of the neck, they were able to turn that anatomical information into data to be put into a phylogenetic software. This software compares the anatomical information preserved in the skeleton with the anatomical information of other already known fossil animals to see what it is most likely to be most closely related to. This analysis found that Mirasaura was a member of the large and unique group known as the Drepanosaura morpha. This group contains mostly arboreal lizard to sloth-sized reptiles that carried around giant forearm-sized claws on their hands and a claw at the end of their long, fat, prehensile tail. They also had domed, bird-like heads, with or without teeth, on necks that did not have any rib bones dangling down from the bottom, as in most other reptiles. Many members of this group diverged from this body plan, such as the leaf-tailed, tiny-skulled, tiny-footed Hyperonectar, the tuatara-like Kyrgosaurus, and the possibly badger-like Skybalonyx. The thing is, though, paleontologists have not been 100% certain as to where this group belongs in the reptile tree. For a while, some members were considered to possibly be some sort of early archosaur, the group to which crocs, birds, and non-avian dinos belong. Some analyses found them to be closer to the pterosaurs, the saurian Quenosaurids, as primitive diapsids, and non-saurian neodiapsids. Whatever finer box they end up in, they were some of the weirdest reptiles to ever live, and they just keep getting weirder. Speaking of which, let's take a closer look at Mirasaura to see just how weird it really is. The skeleton of Mirasaura was relatively similar to many other drepanosaurs, just without some of the extreme modifications taken by the true monkey lizards of the group. Mirasaura had a long, wide torso, with the first handful of back vertebrae sporting thick, reinforced vertebral spines that did not leave a lot of room between one another along the dorsal side or top of the body. The shoulder blades were very long, reaching up as far as the top of the vertebral spines. However, the actual blade part of the shoulder blade was very skinny, while the axe-shaped part is quite large and fused. The limbs are moderate length for a drepanosaur without much robusticity. The feet are adapted for arboreality for sure, with long skinny digits, fat recurved claws, and a reversed toe on the back foot for grasping. The neck is particularly weird and is also a hallmark for drepanosaurs. Most reptiles have little prongs sticking out from the bottom and side of the neck bones, cervical ribs. Drepanosaurs didn't, and neither does Mirasaura. Attached to the neck was a super weird skull with a bulbous dome at the top, giant eye sockets, and a long beak-shaped snout with teeth that stop prior to the premaxillae bones, or the very tip of the snout. Bones out of the way, we can finally get to the showstopper, that fan. Thanks to the various imaging and radiation tests the team did on the fossil, they can rule out that these are feathers. They can also rule out that these things are made of skin. The largest crest fossil, an isolated crest, consists of 20 of these feather-shaped structures. They're aligned along the dorsal midline of the body, tightly overlap one another asymmetrically, and have no real sturdy structure to them, like what you might see in a bird feather. Feathers are basically a bunch of branching keratinous barbs that lock together. Barbs branch off barbs that branch off barbs with a central barb, or what is actually more accurately referred to as a rachis. Each individual structure is not associated with a specific vertebra in the back, so they sort of just erupt from the beginning of the hump near the last of the neck vertebrae and first of the back vertebrae, and then they end around the first third or half of the back. Your first instinct might be that this was a fan that could be flapped up and down for social signaling, but the scans show no form of musculature, skin, or any sort of structure that would have helped the critter move the non-feather, feather-shaped structures up and down. Yes, that's right, it kept that thing erect for all the world to see, 24/7, 365. The structures did have some, well, structure to them. The researchers refer to the material on the outside of the fins as lamina and the thing in the middle as a medial structure. These fins are not like feathers at all, as feathers are composed of keratin, and even the simplest of feathers have a more complex architecture, with a central rachis and individual barbs sticking out from that. Scanning electron microscope imaging allowed the research team to look at the microscopic structures of the fins, which illuminated the presence of melanosomes. Melanosomes were present as 3D bodies or molds left by the actual melanosomes. These melanosomes were not shaped like bacteria, which is often used as an alternative hypothesis to the presence and preservation of melanosomes in fossil remains. The melanosomes are also very similar in structure to those found in fossil and living specimens of birds, reptiles, and pterosaurs, further indicating the validity of the identification of them as actual melanosomes. Oh, yeah, melanosomes are the microscopic organelles that contain pigment molecules to help color the skin or keratin of animals. This is super bizarre to see in an animal that has no evolutionary connection to true feathers, and all the way back in the mid-Triassic no less. It proves that reptiles of all types were doing pretty much anything anyone has ever seen in any animal group. They were doing high metabolisms, fast growth, mass egg laying, parental care, running on two legs under the body, and so much more for a whole long time before the dinosaurs even showed up. The giant back fins of Mirasaura ticked a few boxes in the minds of its descriptors, like there was something they were forgetting about. Alright folks, let's go back to 1970 real quick. 1970 saw the publication of some fossils of another hand-sized lizard-like reptile that happens to be extremely distantly related to real lizards. This time, it was a critter hailing from the mid to late Triassic-aged Madigan Formation of Kyrgyzstan. This critter, named Longisquama insignis, seemed to carry around a fan made up of up to 7 hockey stick-shaped feather-like non-feather structures along the middle of the back. For the longest time, no one was sure exactly where this thing fit in the tree of life, nor whether or not it even had the fan at all. Some researchers and artists came up with all sorts of different hypotheses for the arrangement of Longisquama's perplexing fins. It had 2 parallel rows of them used for gliding. They were actually proto-feathers. They could be lifted up and down like a hand fan, or even that they were plants the lizard-like animal had died on top of. With Mirasaura's similar back fan, the researchers wanted to see how Longisquama would fit if it were added to the mix. They found that Mirasaura and Longisquama were each other's closest relatives as part of a potential Longisquamidae family within the drepanosaur morphoclade. Finally, an identity for Longisquama, a staple in any anachronistic primordial landscape, has been found. David Peters, eat your heart out, you arrogant Dunning-Kruger-affected weirdo. Please go back to paleoart. For the love of God, you're good for virtually nothing else. To get back on topic, the researchers aren't sure exactly what the little critter used its fan for. They think it was most likely for communication between friend and foe, though camouflage cannot be ruled out either. The hump in the back made the fan seem taller, so maybe it was for intimidation, or to bluff predators into thinking the animal was bigger than it was. Speaking of which, I think it's time to bring in everyone's favorite Mr. Man from
Animal Planet's The Most Extreme
to show you just how small the flamboyant little critter was. Based on the tallest fan found among the 80 or so specimens, Mirasaura may have grown to be over 153 millimeters, 6 inches tall, 101 to 127 millimeters, 4 to 5 inches long. That's nothing but a little appetizer. Thanks, Mr. Man. Unfortunately, not much is published on the large vertebrate fauna of the time and place of Mirasaura. It's mostly plants and insects. However, more can be said of the environment in which it lived and died. The sediments Mirasaura were preserved in indicate the area was a transition between freshwater rivers and coastal deltas. Both freshwater and marine organisms have been found in the same Greavoltsia formation, like cnidarians, worms, mollusks, echinoderms, crustaceans, insects, arthropods, and fish. There was a very fragmentary specimen of the giant temnospondyl amphibian Eocyclotosaurus found some time ago, so you can imagine the area contained the usual cast of characters seen in other mid to late Triassic layers. Perhaps the 80 isolated fans suggest Mirasaura were capable of shedding or dropping their fans without risk of death. Or maybe predators were smart enough to snip off the possibly indigestible fan. Who knows? What is known is that Mirasaura is the first among many. Its existence implies a secret diversity among not just the tree-dwelling or subterranean drepanosaurs, but all reptiles during the early days of the Triassic period. As soon as the Great Dying ended, reptiles were doing anything that is everything. Though, now that I think about it while trying to think up a good conclusion for you fine folks at home, this critter sort of puts a nail in the coffin of the birds are not dinosaurs people, huh? Bandits, as they have been unaffectionately named, think that birds are not theropod dinosaurs but must have evolved from a handful of other hypothesized ancestors. Longisquama was used as that possible ancestor for a long while. These bandit people thought that the fans were protofeathers and that Longisquama was an archosaur. Sure, this new analysis with the help of Mirasaura could always be wrong, but considering the much bigger mountain of evidence damn near proving without a shadow of a doubt that birds are just theropod dinosaurs, I think this nudges Longisquama further out of reach. Crazy stuff. The Triassic remains crazy. A generational run for sure. I literally cannot wait for more Triassic oddities to be described. I'm gonna leave you now so I can go find something cool in the Chinle Formation and then name it after an overplayed pop culture reference to piss as many people off as possible. For more interesting stories about nature, the history of life, or what goes bump in the night, subscribe, like this video, drop a comment in the comment section below, and hit the bell icon to stay in the know with everything Edge. Thanks for watching.